everyone, it's Alyssa and welcome to You Can Learn Math. Today is the SAT practice test number 1 that is currently available. This is being recorded in June 2021 and currently this is the practice test that is available free from the College Board. This is the number 1 test. This is section 3. This is the no calculator portion of the test. So anytime you have one that is a no calculator portion, most of these problems, even if they look insane, there's most of them, not all, but the vast majority, there's going to be a quick way to do it. Especially if it looks insane, always look for a shortcut first. So let's just get started. As we go through, I'll also be sharing some little test taking tips along the way. Our first one gives us this. If x minus 1 over 3 is equal to k and k is equal to 3, what is the value of x? All right, this one we're told k is 3, so substitute it right there for k. Put 3 in there. That gets rid of that variable k. And now this is a more simple one variable algebra problem. To get x by itself or solve for x, first thing we have x minus 1 divided by 3. So let's get rid of the divided by 3 by multiplying both sides by 3. That undoes that. We are left with x minus 1 on the left and 3 times 3 or 9 on the right. Then to get x by itself, we want to undo the minus 1, so we will add 1 to both sides. X then equals 9 plus 1 or 10, which is option D on the test. Problem 2. For I equals square root of negative 1, what is the sum 7, not a T, 7 plus 3i plus negative 8 plus 9i? Two things. They're trying to trick you a little bit here by giving you this first, saying that for I equals the square root of negative 1. So that's a little scary, like, square root of negative 1, how do I deal with this? In this particular problem, it doesn't matter. It doesn't matter what I equals in this case. This could be any variable, not just a standard like I. It could be just an x, and that would be the same thing. Because we're not doing anything with I as far as multiplication or division, it's just adding. Also, because this is a plus between these two parentheses, not a minus, a multiply, a divide, it's just a plus, it is the same as if these parentheses were not there. Honestly, this is just a straightforward combining like terms. So 7 and negative 8, combine those to be negative 1. And I can combine 3i and 9i to be 12i. That's it. That's all there is to it. And that is option A. Number 3. On Saturday afternoon, Armand sent M, an unknown number, this is our unknown number, of text messages every hour for 5 hours. This is our Armand. And then we have Tyrone, who sent P, that's another unknown number, of text messages every hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? Okay. If this is hard to visualize, like, how do I represent this? The options that they give us as answers, we have 9MP, 20MP, 5M plus 4P, and 4M plus 5P. All right, if this is hard just to look at and go like, oh, I know this. Here's a way to visualize it. Put real numbers in there. Instead of M, think about it. If he was texting 3 texts every hour and he did it for 5 hours, how many texts would he do? Did he do what he do or did he do? If he did 3 an hour for 5 hours, you would multiply 3 times 5. So we put in a 3 for M. Well, let's change this back to an M. So that's an M times 5. Same down here. What if this P was 2 texts an hour for 4 hours? Well, we would multiply, right? 2 times 4. But it's not a 2, it's a P. This unknown number is P. So P times 4. We can write M times 5 as 5M. We can write 4 times P as 4P. So the grand total would be to add these together, or, oops, I circled the wrong one. Sorry. Option C, 5M plus 4P. There you go. Number 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day, this is number of phones at the end of each day, can be estimated with this equation that they give us. P equals 108 minus 23 times D. P is the number of phones left. Pardon my awful handwriting here. And D is the number of days worked. Okay. So let's put in some real numbers and kind of visualize this. If she has worked 2 days, how many phones does she have left? It's 108 minus 23 times 2, 2 days. So 108 minus 46 equals 62. She has 62 phones left. So every day this number is going up. We're subtracting more phones. So what can we infer then? That this means that she's fixing 23 phones a day, because after 2 days we're subtracting 46. After 1 day it would have been just 23. Then after 2 days, she subtracts 46, so she has 62 left. So we can deduce then here, this is representing the number of phones per day times how many days. So then what is 108? That's the starting point. That's where she starts, how many phones she has at the beginning of the week. So we look at our options, and option B says, Kathy starts each week with 108 phones to fix. That is what 108 means. She starts with that many phones, and then each day she is fixing 23. Right, number 5. Which of the following is equivalent to this expression? All right, this is our expression that we're given. X squared y minus 3y squared plus 5xy squared, all in parentheses, minus, all in parentheses. It always does this. It likes to float over to the side. Stop that. Minus x squared y plus 3xy squared minus 3y squared. Okay, there's 2 things here where they're trying to trick you. I'm going to highlight them. All right, 1, this is this negative right here. This applies to everything in that parentheses. It's minus all of that, so we have to be very careful. The other thing is, look at our order here. We have an x squared y, then x squared y. 3y squared, 3y, no. 3y squared. They've put them out of order because it's very, not logical, but it's normal. I'll say it's like a normal reaction or normal response to go first terms together, second terms together, third terms together. And they've deliberately switched these 2 to make it more confusing. I see you there. All right, so first let's handle this minus where we're subtracting everything on the right. I know when I'm looking at this that this could cause problems, so I want to change this to a plus sign to make things easier. When I do that, I have to change the sign of everything inside this parentheses. So this becomes a plus, this becomes a negative, this becomes a plus. Okay? Once I do that, I can get rid of the parentheses and just worry about combining like terms. And there's the second trick. Make sure we have the correct like terms together. So I'm going to rewrite them. X squared y, and I'm going to mark them out as I go, plus x squared y. There's that one. Minus 3y squared plus negative, oh, sorry, see, I did it too. I started writing that one. It's so easy to do. Plus 3y squared. This is why I say this. Plus 5xy squared, especially on the day when you are just flying through this. So easy to mess these up. Plus a negative 3xy squared. Now they are paired together. The like terms are paired, so I can combine them quite easily. X squared y plus x squared y, so I have two x squared y's. Negative 3y squared plus 3y squared, those cancel out. That's nothing. There's 0. And last, a positive 5xy squared plus a negative 3xy squared. So 5 minus 3 essentially is going to be a positive 2xy squared. So our final answer is 2x squared y plus 2xy squared, which is option C. Number 6, we are given this equation. H equals 3a plus 28.6. We're told a pediatrician uses the model above to estimate the height. Okay, this is our height of a boy. Excuse me, just choked a little bit on this little pollen here where I'm at. The height h of a boy in inches in terms of the boy's age in years between 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? This is one, there is a little bit of a shortcut here. There's nothing wrong with filling this in, like saying, okay, if it is 2 years, when the boy is 2 years old, it will be 3 times 2 plus 28.6. At 3 years, it will be 3 times 3 plus 28.6. 4 years, 3 times 4, like this, and doing that math and then figuring out the difference. There's nothing wrong with that, but that is a little bit of extra time, and time is a premium in these tests. That you want to do it accurately, yes, but quickly. So the thing to kind of look at, the epiphany, I guess you'd say, they want you to have is this isn't changing, that 28.6. So every single year, the increase in height, it does not happen here. It's happening here. So in that first year, it's 3 times 2, or 6. Next year, 3 times 3, or 9. 3 times 4, or 12. It's increasing by 3 every year. So that is our answer. Option A, the answer is 3. Question number 7. Now this one, you look at it, it looks like a doozy. And you go, how on earth am I going to do this at a glance? And it's going to take me a second just to write it all down. So look at all this. This is craziness, right? And you're like, without a calculator, what on earth am I supposed to do with this? All right, 2 things I want to note. First, if you come across a problem like this and you do not immediately, and this is true with any of these math problems, if you do not immediately look at it and go, oh, I know how to do this, and I know how to do this quickly, mark it, skip it. And I mean mark it as in like make a note to come back, not mark it on the test, the entry answers, not the answer page. Make a mark to remind yourself, I need to come back to this, and skip it. Move on. Do not waste time puzzling over something where you do not immediately know how to answer it. That is wasting time when there are problems later that you might be able to very quickly answer and get those points. There's always, if you go through and you do the rest, there's always an opportunity. You can come back to it at the end. Just don't forget about it. Second thing, this looks very time intensive. However, as I've said, this is a fast, no calculator based test. This is also number 7 out of, is it 20? I think it's 20 in this section. Let's double check. Yeah, 20. 7 out of 20. They tend to, not always, but tend to get harder as they go along. So number 7 shouldn't be the most insane problem on this test. So let's look what they're asking. It says the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. That's a lot going on. You go, wow, what am I going to have to do with this? But here's the question. Which of the following gives P in terms of M, R, and N? Anytime you say this, it says which of the following gives P in terms of this, they're wanting you to get P by itself and equals and everything else on the right-hand side. That's what they're looking for. So for example, if you've seen like distance equals rate times time, and they go, what is this in terms of T? Well, it gives this, or gives T in terms of R and D, excuse me. So they want T by itself. So you go, okay, I'm going to divide both sides by R. T equals D divided by R. So here I am giving you T in terms of D and R. That's what they mean. Isolate this, get it by itself. So here's the thing. I know that this equation looks ridiculous. This whole big equation looks insane, but it's a unit. It's this whole unit, and P is essentially by itself just being multiplied by this unit. So that's helpful. Look at this in terms, I'm going to replace this with a more quote-unquote normal looking fraction. What if it was like this? How would I put this? How would I do P in terms of M? And I want P by itself. I would get P by itself by getting rid of this fraction. How do we get rid of a fraction in algebra? We multiply by the reciprocal. We do this to both sides. We multiply by the reciprocal, that gets rid of it, right? So then I am left with P equals 4/3 M. And you can see how this gets rid of it. If I just do it off to the side here. What happens if you multiply those together? 3 times 4 is 12. 4 times 3 is 12. 12 over 12 is 1. So it's just 1 times P. The fraction has essentially disappeared. So that is our principle. I can get rid of this whole unit if I multiply by the reciprocal. So that's what we're going to do. That's all it is. We don't have to do anything with all that. We're just going to multiply it by the reciprocal. So I am just, because that's so much to write, so I'm multiplying by the reciprocal. I'm cheating here because, yeah, I'm only human. I don't want to write that mess more than I have to, right? So we multiply by the reciprocal. I will be left with P by itself, and on the other side will be the reciprocal of that. I will write it this time. So that 1 plus R over 1200 to the power of N minus 1 all over R over 1200 times 1 plus R over 1200 to the power of N all times M. That's my answer. That's all I had to do was flip that huge equation, that huge fraction upside down to make a reciprocal and multiply it by both sides. Okay, so if you look, and be careful when you look, that is option B for your choices. So if you know that about the fractions, you could do that very quickly, and it clearly looked like something that was not a quick problem. All right, number 8. If A divided by B equals 2, what is the value of 4 times B divided by A? There's two ways to do this. You can do this algebraically, or you can do this quickly mathematically. So here's a mathematical function. And again, time is of the essence on these things. All they're caring about is that you put the right number down on that answer sheet. In this section, you do not have to show your work. They're not counting it based on your work. So here's something you can do. A divided by B is 2. What are two numbers that would fit in here? Let's say, 6 divided by 3 equals 2. That's true, right? Now let's put those in there. 4 times, because I've said this is my A and this is my B. So 4 times B, or 4 times 3, divided by 6. 12 divided by 6, 2. Okay. You go, is it really that easy? It is. I'll show you real quickly another one, just if you don't believe me. 10 divided by 5 equals 2. 4 times 5 divided by 10, 20 divided by 10 equals 2. That is a very simple way to do this. Just plug some numbers in and solve it. If you want to see why this works algebraically, here's how it goes. A over B equals 2. I go, I'm trying to make it look more like this. So first, B needs to be on top and A on the bottom being divided. So what I'm going to do, I'm going to multiply both sides by B. I get A equals 2 times B. That's looking closer. Then I'm going to divide both sides by A. That gets me my A on the bottom. And A divided by A is 1. We're assuming A does not equal 0. And so 1 equals 2B over A. Well, how do I get from 2B over A to 4B over A? I would multiply by 2. And that would give me 4B over A, right? So that's what I'm going to do. I'm going to multiply both sides by 2. And I get 2 equals 4B over A. Same answer, different method. Both work. Right, on to number 9. Number 9. We are given these two equations. 3x plus 4y equals negative 23. 2y minus x equals negative 19. And they want you to get the solution to this system of equations. We are given these answers: negative 5, negative 2, 3, negative 8, 4, negative 6, and 9, negative 6. With a system of equations, the ways we normally solve them are either with substitution or elimination. Sometimes on an SAT question, again, we're talking about time, it might be advantageous to simply plug some numbers in and see if it works. If you're really fast with your math, that might work for you. That might be a good option. It just depends. It depends on you. However, I would say absolutely it's important to know how to do substitution and elimination, because sometimes in the question section where they make you actually enter your answer, you have to enter the answer in the little grid freehand and you're not given multiple choice. So it's good to know how to do this. One thing, a little test strategy, look at the answers over here. If you notice, 2 of these have the same y value of negative 6. So whichever way I do, substitution or elimination, I want to do it so that I solve for x, not y. Because if I solve for x, I already know my answer. I don't even have to solve for y for this particular test question. So that's just a little strategy. Save you a little bit of time. So I want to solve first for x. Here's one thing, if you'll notice that they were being a little tricky. Normally when you're given these equations, the x's and the y's are kind of lined up over each other. Here, they are not. We are given the x first here, but the x second there. So the first thing I'm going to do is I'm going to write them like that. So they are lined up, and it makes it easier for me to see what I should do. Now I want to solve for x, which means I'm going to choose elimination. I want to eliminate the y. That will give me my x. So to eliminate the y, I see I have 4y positive and then positive 2y. They need to cancel out so they can be eliminated. To make 2y into something that will cancel 4y, I'm going to make it a negative 4. To do that, I need to multiply this whole thing by negative 2. Okay, so negative 2 times negative x is 2x. Negative 2 times 2y is negative 4y. And negative 2 times negative 19 is positive 38. All right, and I'm going to rewrite the other equation right above it. I'm going to then add them together. And then my y's, and that looks like an x. That's not, that's a y. The y's cancel out. 3x plus 2x is 5x. 4y minus 4y is nothing. And negative 23 plus 38 is 15. I can then divide both sides by 5 and x equals 3. I now know my answer. It's 3 and negative 8. If you have the time, it is not a bad idea to actually plug these two numbers into here and see if they work, or to simply use the x equals 3, plug it into one of these two equations and see if you get negative 8 for y. Again, I would only recommend doing that if you have the time. Assuming that you did this math part pretty clearly, you can have confidence that knowing x equals 3, this is your answer. And it is. Number 10, g of x equals a times x squared plus 24. For the function g defined above, a is a constant and g of 4 equals 8. What is the value of g of negative 4? There's two ways to do this. One is sort of an intuitive, quick shortcut way. The other is the more mathematical, algebraic way. I'm going to show you both. They're telling us that a is a constant, so a is just a number. So if g of 4 equals 8, what that means is if I plug 4 in for this x, I will get 8 after I do this math. That's what this notation means. G of x means do these things to x. So g of 4 means I did these things to 4 and I got 8. So let's plug that in. There was a constant. It was multiplied by 4 squared. There's my 4 putting in. And then 24 was added and I got 8. 4 squared is 16, so 16 times this constant plus 24 equals 8. Now this is a pretty straightforward algebraic expression. I'm going to subtract 24 from both sides, and I get 16 times a equals negative 16. Divide both sides by 16. A equals negative 1. Okay? A equals negative 1. I'm going to erase this to give me a little room. Now I can plug that in. Negative 1 times x squared, I'll write it like that so it's a little clearer, plus 24. Now it's saying what is g of negative 4? So I'm going to plug negative 4 in there. Negative 1 times negative 4 squared plus 24. Negative 4 squared is 16 times negative 1 is negative 16 plus 24 equals 8. 8 is my answer. Now here's the intuitive shortcut thing I mentioned that I'm going to rewrite this just so it's a little clearer. Okay, I am told g of 4 equals 8. And they want to know what g of negative 4 is. Here's the thing. If I plug 4 into this equation, 4 squared is 16. So 16 goes here, it's multiplied by a constant, 24 is added, and I get 8. What happens if I plug negative 4 in for x squared? Aren't I going to get 16 again? So nothing has changed. So the shortcut is like, wait a minute, if I plug negative 4 into this, I get 16. So the same process will happen and 8 will spit out again. The answer is 8. So you don't even have to solve for the constant. Again, if you don't realize that and you do it mathematically and you solve for the constant, no big deal. But just if you can have those moments where you realize something like that, it will help you because you save time. Right. Next one, number 11. B equals 2.35 plus 0.25x. C is equal to 1.75 plus 0.40x. In the equations above, B and C represent the price per pound in dollars of beef and chicken. B and C, okay? X weeks after July 1st during last summer. So X is the number of weeks since July. Okay? What was the price per pound of beef when it was equal to the price per pound of chicken? Two things. One, these are essentially lines that are being drawn. We have this price per pound of beef that's going up over time, and this price per pound of chicken that's going up over time, and there's a point where they intersect. That's the point where they're the same. So you're basically saying, where do these lines cross? Well, we don't have a graphing calculator, and this is kind of hard to graph. So what's the best way to do this? The best way to do this is, we know this would happen at the same time, right? There's a time, so many weeks after July 1st, that they had the same price. So my X is going to be the same in both of these. So an X will be spit into this, will be put into this equation, and it will spit out a number. Same thing here. It will spit out a number. These two numbers will be the same. So how do I solve this? Easiest way, set these two equations equal to each other. And then solve for X. And I'm getting punchy. I've been doing this for a while because I am making silly mistakes when I'm writing. Woohoo! Okay. Now let's solve for X. That's part one, but that's an important part. All right, first I'm going to subtract $1.75 from both sides. I get 0.60 plus 0.25x equals 0.40x. Then I'm going to subtract 0.25x from both sides. And that gives me 0.60 equals 0.15x. I'm going to divide by 0.15x. This is going to be the same as 60 divided by 15. So x is equal to 4. Now you may have noticed, if you're looking at the problem, 4 is not an option that's provided, which I actually think if they were being really tricky, they should have provided 4 as an option, because I imagine a lot of people go, 4, that's my answer. Now remember, the x is the number of weeks after July 1st. So we need to know, what is the price of beef at this time? Honestly, it doesn't matter if I plug that 0.25 into the beef or the chicken equation, because remember, it's the same price. It doesn't matter. However, if so it doesn't matter if I plug that 4. If I plug that 4 into the beef or the chicken, because remember, they're the same price. You know, it doesn't matter. However, I'm going to plug it into the beef one because, look, 0.25 or a quarter, 25 cents, times 4 is $1. So the beef equals 2.35 plus 0.25 times 4 is $1 or 1. So the price is $3.35, which is option D. Next one, a line in the XY plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? We are given 0, 7, 1, 7, 7, 7, and 14, 2. Okay. So when you have slope 1/7. This is rise over run. It's how much it goes up or down, that's the rise, over how much it goes left to right, that's the run. Okay, so this one rises 1 and then runs 7. So it goes up and then over, and this is actually the point on the line. This is our line right there. And then it's going to do the same thing again. Going to go up 1 and over 7. All right, so if it's gone up 1 and over 7, this point right here is going to be the x-coordinate is 7 and the y-coordinate is 1. We do not have that as an option amongst our answers. So let's look at our next one. It goes up 1 more and then it goes over 7. So it's going to go up 1 more. Our y is going to increase to 2. Our x is going to go up 7 more to 14. 14, 2. That point's on the line. That's really all there is to that one. Okay, on to 13. If x is greater than 3, which of the following is equivalent to 1 over x plus 2 plus 1 over x plus 3? We want to get rid of fractions inside of fractions. We do not want this. And if you look at the answers here that they're providing, there are no fractions inside there. Without really looking at what's here, let's try simplifying this without looking at the answers that are provided. So to simplify this, we're going to need to get rid of these in the denominator, in this fraction inside a fraction. Okay? Excuse me, I have the hiccups. So there needs to be something on top that will cancel out these on the bottom, but they don't match. I have an x plus 2 and an x plus 3. So I need to have an x plus 2 and an x plus 3 above both of these. My stylus is really not working well. It's making all these lines. I'm sorry about that. I need to have it on both of them in order to cancel it out. To get that to happen, this one's a little more confusing, I know. You need to multiply this whole thing by x plus 2 times x plus 3 over x plus 2 times x plus 3. So when that happens, because remember we do fractions, okay, you multiply everything on the top, you multiply everything on the bottom. So on the top, I'm going to get x plus 2 times x plus 3. On the bottom, I am multiplying this times x plus 2 times x plus 3, then this times x plus 2 times x plus 3. So let's take our first one. When we multiply it times x plus 2 times x plus 3, we get this. And when we do the second one, we get this. Right, now when we have things being multiplied in fractions, if we have matches on top and bottom, we can cancel. So x plus 2 is being multiplied by x plus 3, so we can cancel that one. And on this side, we can cancel this one. Okay, this is just such a messy problem. All right, so let's simplify. On the bottom now, I just have x plus 3 plus x plus 2. The fraction's gone. On the top, I have x plus 2 times x plus 3. Now, if we look at our options, we can see that none of the answers have parentheses in them. So they want us to, so I'm not going to really look at the options any further, just I'm going to glance and go, oh, no parentheses, so they want me to simplify further. Okay. So on the bottom, I'm going to combine like terms. I can combine the x's to give me 2x. I can combine the 3 and the 2. I'm just adding together, not multiplying. 3 plus 2 is 5. On the top, I'm going to use FOIL or distribution, depending what your teacher has called it, and multiply everything. I'm doing this very quickly. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. And then these like terms, 3x and 2x, can be combined to be 5x. So x squared plus 5x plus 6 over 2x plus 5, which is option B. Next, we have number 14. If 3x minus y equals 12, what is the value of 8 to the power of x over 2 to the power of y? The options we're given are 2 to the power of 12, 4 to the power of 4, and 8 to the power of 2. Or our last one, the value cannot be determined. All right. I would like to, first thing, I want to get this so it has one variable and one variable only. I think the easiest way, if I'm looking at this, I would go, y, I can get y by itself pretty easily. I'm going to add y to both sides, so that makes it positive, which gives me 3x equals 12 plus y. Then I'm going to subtract 12 from both sides. That gives me that y equals 3x minus 12. So I'm going to go up here, and I'm going to replace that. 3x minus 12. Right, now the rule that they're looking for you to know in this, and I'm actually going to, I'm going to get rid of this. So we've used that. That's done. Okay, the rule that they're looking for you to know is this. If I have things with the same base, such as, actually there's two rules. We'll get into this in a second. All right, two rules. Here's the first rule, actually. They want us to know if I have something that looks like this, 3 to the power of 2 to the power of 10. This is equal to 3 to the power of 2 times 10. You multiply them. That's rule number one about exponents, which you're going to need to know for this. You multiply the exponents when it's a power to a power. If you are dividing and you have the same base, if you're dividing exponents, like say 4 to the power of 5 divided by 4 to the power of 2, you subtract the exponents. 4 to the power of 5 minus 2, or 3. Those are the two facts about exponents that you need to know to be able to do this problem. Okay, so I've got 8 to the power of x divided by 2 to the power of 3x minus 12. They don't have the same base. I've got an 8, I've got a 2, not the same base. So I want to change that 8 so it has a base 2. What is 8? 8 is the same as 2 cubed. 2 times 2 times 2. So 2 cubed to the power of x. Well, my power to the power rule says I multiply those. So that's the same as 2 to the power of 3 times x. So I'm going to plug that back into my original one. I now know that 8 to the power of x is the same as 2 to the power of 3x. And on the bottom I have 2 to the power of 3x minus 12. Well, this is division. Division says if I have the same base when I'm dividing exponents, I can subtract. So 2 to the power of 3x divided by 2 to the power of 3x minus 12 is the same as 2 to the power of 3x minus, actually I want to get rid of this parentheses, just use it here, 3x minus 12. Man, that mouse is just bouncing everywhere. Why is it doing that? I don't know. It's really annoying. Sorry about that. Okay, so 3x minus 12. So I'm going to change the signs to make sure. There we go. So 3x plus a negative 3x, that cancels out. That's 0. And I'm just left 2 to the power of 12. Okay. I know that looks crazy, but yes, 2 to the power of 12 is the answer. Clear that canvas. All right, number 15. We have ax plus 2 times bx plus 7. Okay, and we're told that this equals 15x squared plus cx plus 14 for all values of x, and that a plus b equals 8. What are the two possible values for c? There's two possible values. They are counting on you knowing about FOIL and what happens when you multiply things with FOIL. FOIL is another way of saying how we distribute two binomials. Okay, any of these things I have videos on if you have questions, further questions on more details. You can look in the description. I've got stuff on this. Okay, so our first one here, the first term when we're doing FOIL comes from multiplying these first terms, ax times bx. The x's multiplied together give you x squared. So now we know that a times b, I'm getting ahead of myself, equals 15, and a plus b equals 8. What multiplies to 15 and adds to 8? 5 and 3. The only two things that multiply to 15 that would add to a positive number would be 1 and 15 or 5 and 3. It's 5 and 3. So now I know that either A is 5 and B is 3, or A or B is 5 and A is 3. It doesn't matter how I write it. Yeah, same difference. Okay, so they want to know what C is. Well, let's plug those things in there and see what would happen. All right, so if I put in 5 for A and 3 for B, or 3 for A and 5 for B. So they want to know, what will C be? What is that middle term going to be? Well, in my first one, I'm going to have 2. I'm just going to look at just that middle term. That's all I really care about. 2 times 3x, that's 6x. And I'm going to have 7 times 5x, 35x. My middle term is going to be 41x. We'll have 2 other terms. I'm only focusing on the middle. Next one, 2 times 5x is 10x. 3x times 7 is 21x. My middle term there is 31x. So C will either be 41 or 31, which is answer D. Now we're on to the section where you have to come up with the numbers on your own. No multiple choice. Number 16. If t is greater than 0 and t squared minus 4 equals 0, what is the value of t? Okay, t squared minus 4 equals 0. We would add 4 to both sides, and we get that t squared equals 4. To square something means to multiply it by itself. So what times itself, what number times itself equals 4? Two numbers, -2 and 2. But we are told that 2 is greater than 0, so this one's out. Our answer is 2. Number 17. We have this drawing. Boom, looks something like this. I know my the side is really bad. Okay, B. What is with my stylus? It is not picking up as I'm writing here. Okay. E and A. And we're told this is, we have this, this is X. I actually want to write that in red so we know that's X, this side right here. All right, we're told a summer camp counselor wants to find the length X in feet across a lake. This is our lake. Whee, isn't that a nice lake? The lengths represented by AB, EB, BD, and CD, or on the sketch, are determined to be 1,800, 1,400, 700, and 800 feet, respectively. When they give you a string of numbers like this, start writing on that paper. Start filling things in. All right, so AB is 1,800 feet. EB is 1,400 feet. BD, okay, BD is 700 feet. And finally, CD is 800 feet. Segments AC, okay, this whole AC, and DE intersect at B. All right, well, we could see that, but, you know, that's nice of them to tell us that. And angle AEB, this one, and CDB, this one, have the same measure. What is the value of X? All right, what they're wanting you to know, this is a rule in geometry, and if you don't know this rule, you know, it's a bit hard. Two things. They want you to know that vertical angles or opposite angles, depends on your book what they're called, they are congruent. So this angle and this angle are congruent. They're the same. That's the first thing they want you to know. Second thing they want you to know is that two triangles that have two congruent angles, two angles in common, are similar. Not congruent, but they are similar. That means they are proportional. They can be enlarged or shrunk to match each other. All right, so let's visualize this. We have to make sure we're lining up the triangles correctly. So man, that mouse just is bouncing. I don't know what's wrong with it. Okay, so our first big triangle, I'm going to write it like this. Wow, I'm just really not good at drawing triangles here. Awful. All right, so there's A, B, E. I've just rotated it a little bit. We have 1800, 1400, and we have X. Okay. Then we have the smaller triangle. I am just really not good at drawing these triangles today. We are given this is 700 and this is 800. See, I'm lining them up so that they are corresponding. Now I can see that to get from 700 to 1400, I'm multiplying by 2. These proportions are always the same. So here I'm getting from 800 to X. I need to multiply by 2. 800 times X is 1600. That's your answer. That's it. So saying what is 800 times 2 is not hard, but you have to have that knowledge. And if you haven't learned that yet, yeah, it stinks, but this is why we practice before SAT tests, right? Okay, next we're given a system of equations. X plus y equals -9. X plus 2y equals -25. And this, again, this is number 18. I should have said that. This is number 18. We can solve this one of two ways really easily. We can do this as substitution. We can do it as elimination. I'll do it both ways. If we do it as substitution, I'm going to multiply everything on top here by a -1. That's going to change everything. I'm just going to go through and change it. If I multiply each of these by a -1, that becomes a negative, that becomes a negative, that becomes a positive. If I add these together, my x's cancel out. -y plus 2y is just y. 9 plus -25 is -16. Then I can plug that into the top. X plus y equals -9 is what we're told. I can put that -16 in for x. Gonna be nice now, mouse? Are you gonna behave? Okay, we'll try. All right, so then we would do plus positive 16 to both sides. X is equal to 7. So I get that y equals -16 and x equals 7. Okay, and my cat is jumping on my computer. Please don't do that, honey. I love you, but come on. Okay, so let's go backwards a little bit. Now again, they did ask what is the value of x. So if you decided I would rather eliminate y and just go, straight for the x, we can do that too. To do that, we would multiply everything here by -2. That would make this a -2x, a -2y, and this would be a positive 18. So I've multiplied everything by -2. Then if I add them together, -2x plus x is -x. The y's cancel out. 18 plus -25 is -7. If -x equals -7, divide both sides by -1, x equals 7. The other way to do this is substitution. We have x plus y equals -9. Frankly, I think elimination is the way to go with this, but you can do it either way if you want to. I'm going to solve for y here, so I can plug it in down there and get my x first. So I'm going to subtract x from both sides. Let me write that down real quickly. Subtract x from both sides, and I get y equals -x minus 9. Once I know that, I can plug that back into this equation up here. So I'm going to do that. So x plus 2 times -x minus 9, because that's what y is equal to, equals -25. I get x plus a -2x minus 18 equals -25. X plus -2x is -x minus 18 equals -25. Then I add 18 to both sides, and I'm back with -x equals -7, or x equals 7. Okay, again, I'm going really quickly through these. If you'd like more tips on elimination, substitution, I have videos on that below. Number 19, in a right triangle One angle measures x, where the sine of x equals 4/5. What is the cosine of 90 minus x? There's two ways to go about this. One is if you happen to know the complementary angle relationship with sine and x. It says that this is the rule. Sine of x and cosine of 90 minus x are the same. So if you learned that fact, that these two things are the same, that you would know this is 4/5. You would know that. However, if you were not taught this or you haven't learned this in school, but you know what sine and cosine mean in terms of a triangle, here's a way to look at it. Think about a triangle. If I have a right triangle, what does sine mean? If you've learned the SOHCAHTOA abbreviation, sine is opposite over hypotenuse. So I have this angle x, and opposite it is 4, and the hypotenuse is 5. Okay, that's what sine means. And we have opposite over hypotenuse. There's my opposite, there's my hypotenuse. Okay, so cosine of 90 minus x. Think about this triangle. This is a right triangle, which means this is 90 degrees, right? All triangles add up to 180. So if this is 90, these two added together must also be 90, since all three are 180, right? So this is 90. These two have to be 90 when you add them together. So if this angle here is x, this angle could be called 90 minus x, right? And what is cosine? Cosine is adjacent over hypotenuse. What's adjacent to this 90 minus x triangle? 4. What's the hypotenuse? 5. Right. That's why it's the same. And finally, number 20, if a equals 5 times the square root of 2 and 2a equals square root of 2x, what is the value of x? Right, I know to get from a to 2a, I multiply by 2. So stands to reason, algebraically, if I multiply this by 2, I will get to this. So let's do just that. I'm going to multiply this top one by 2, and I get 2a equals 10 times the square root of 2. Okay, so now I know 10 times the square root of 2 equals the square root of 2x, because 2a equals 2a, same thing, so these must be equal as well, right? Right. So 10 times the square root of 2 equals 2x. So that's all I'm going to look at right now. I want to solve for x. We can square both sides. All right? So 10 times the square root of 2 squared is 10 times the square root of 2 times 10 times the square root of 2 equals, and on this side, that just gets rid of the square root. So 10 times 10 is 100. Square root of 2 times square root of 2 is 2. So we can see where this is going. 100. You can see how, well, you can just go, I don't even have to simplify that. I'm just going to divide both sides by 2. That gets rid of the 2 on the right side, and 100 equals x. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.